All right, everybody. So we have Dr. Cody Haun back with us today, and actually Dr. Mike Roberts hiding somewhere back there.
There he is.
How you guys doing?
We're great.
Good.
How
And
are you,
who's
man?
our third guest back there?
Chris Van.
What are you doing, Chris?
So I am just finishing up my dissertation project. So hopefully, doctor soon.
Awesome. Very cool. So, Cody, last time we had you on, we kind of talked about the recent paper that had gone out. You said this is kind of a follow-up. What Chris is doing now is kind of a follow-up to that. So can you just kind of explain what we're trying to figure out with this, or because you guys just finished up today, right?
Yes, that is correct.
Yeah, literally like 20 minutes ago.
Awesome.
So
All right. So this
got
is
done
first
with-
look.
Doc, you did how many biopsies today?
Chris did some of them, so
Yeah.
that helped.
Yeah.
But we did a total of 30 biopsies.
Wow.
Yeah.
And how long has this study been running?
So we just finished 7 total weeks, 6 weeks of training, 1 week of passive recovery. We had a pre-biopsy, a post-biopsy after 6 weeks of training, and then 1 week later, which is today, that was our post-passive recovery biopsy.
Okay. So I am, and I'm sure most people listening are completely unfamiliar with what the study is and what we. So can you just give me a brief overview, or it doesn't have to be brief. You can give us as comprehensive an overview as you want of what you guys were looking at.
So really, we found an interesting phenomena with Cody's dissertation study, where it seems like sarcoplasmic hypertrophy, or this concept of the sarcoplasm increasing, seemed to happen. And we found that really when we started to equate for extracellular fluid shifts after voluminous training. So that led Cody into spearheading a review article that we wrote on the biological construct of skeletal muscle hypertrophy. And as we were doing the literature review for that, we actually found several papers that had examined or found this phenomena. So we wanted to kind of interrogate that a little bit more and figure out, well, if we have an increase in the sarcoplasmic fraction, what's causing an increase in the myofibrillar fraction, or the contractile portion of the muscle cell? So that's really what this study was designed to do. So the participants did unilateral training. One leg was high volume, starting at 10 sets per week, working up to 20 sets per week total. The other leg stayed constant at 9 sets a week, but they were sets of 5 instead of sets of 10. And they started at 82.5% of their estimated 1RM, worked all the way up to 95% of their 1RM.
So the group with the 9 sets did that, and then what was the percentage for the other group? Or was that
So that
cross?
was 60%,
Okay.
mirrored directly to what Cody had done.
Gotcha. Okay. And so since you guys just finished, I mean, have you been like analyzing along the way? Do we have anything to report about this, or is that something we can't talk about yet?
So we have not analyzed anything yet.
Okay. So what's your hypothesis here?
So the hypothesis, the working one, is the high volume leg would experience an increase in the sarcoplasmic fraction, or enzymes and proteins responsible for ATP production. And then the high intensity base leg would, in theory, experience myofibrillar protein synthesis. So actin, myosin, titin, things like that. So that's
Gotcha.
the working rough model hypothesis.
So, and you can answer this, Cody, you can answer this, anybody. I think a lot of this, and I think I was actually talking with Andrew Vygotsky a little bit too, how I feel like at this point, a lot of this research might not change practically what we're doing in the gym, but it helps us understand why we're seeing what we're seeing in the gym. Would you agree with that, or do you think we're really getting some, practical advice from these studies? Are we really going to be able to take away and change what we're doing in the gym from the results of these kinds of studies?
Well, yeah, I mean, I hope so. That's kind of the point for us. Dr. Roberts' lab is called the Molecular and Applied Science Laboratory. So the slogan for the lab is bridging the gap between molecules and man. So the idea, right, is that we can use molecular biology and studies like this to chase mechanisms, but eventually we want to apply those in the practical setting, right? And we want it to help people reach their fitness goals or improve their health. So, yes, I absolutely think that the outcome of these studies will eventually be that some of the information that we can glean from the studies can be applied in some way. But let's just stick to sarcoplasmic versus myofibrillar hypertrophy as an example. Let's say that in this study, we find that the leg that trained with higher intensities on average accrued more myofibrillar protein, and that occurred alongside increases in strength, whereas the other leg didn't accrue as much myofibrillar hypertrophy or myofibrillar proteins and perhaps more sarcoplasmic proteins, and that leg didn't improve in strength as much. So what do we do with that information? Well, I think practically speaking, if you want to get stronger, that probably involves the accrual of myofibrillar proteins and lifting higher intensities on average. So, I mean, I think that's a very practical way of bridging the gap between some of these molecular assays and practical outcomes. So, what would you say to that, Doc?
I agree. No, Cody summarized it well. And there's a study I showed Dan yesterday, and you've probably seen this, but they had older people lifting at around 55% 1RM. So that's what Cody and Dan did. And they did that for 24 weeks. Then they took a 48-week hiatus from lifting. Excuse me. So they had one group do 55% 1RM for 24 weeks. The second group did around 80 or 85% 1RM for 24 weeks. So it's parallel design. And then they had them take a hiatus for 48 weeks and retested their strength. And to Cody's point, those that lifted the heavier weight still maintained strength above baseline, whereas the group that lifted 55% 1RM, after that 48-week hiatus, they were back down to baseline. Usually neural adaptations are very rapid, so I don't think that's a 48-week hiatus in terms of lingering neural adaptations, keeping the high-intensity group stronger. And so I think to Cody's point, that could be because of 24 weeks of high-intensity training elevated the contractile protein component.
Yeah.
That's our
did I
hypothesis.
hear that right? That you said after 24 weeks they took 48-week hiatus,
That's correct.
They were still above baseline after that long?
Yeah, and it was pretty robust. I mean, it was. I can send you that paper.
Yeah.
And it's pretty. I don't know if you have show notes, you can post it, but anyway, I mean, it was, especially for the legs, it was very, very well elevated. So yeah.
Wow. And this was an older population as well?
This was in older people. So I think on average it was 70 years old.
Oh, wow.
Yeah.
That is actually pretty surprising to me. That's cool.
So in response to Cody's point, like the broader, when you start talking about resilience to frailty, sending the message that you don't want to lift neon dumbbells to failure because if you have to get injured or whatever, especially in that age group, that could be counterproductive, right? That's kind of the idea.
Yeah, and I think that's a great example because my not counter argument, but I guess like playing devil's advocate to what Cody had initially said, you were saying, well, if it shows us this, and I would say that's kind of, again, showing the mechanism behind it, but nice trio there.
Yeah.
But like, again, that's showing the mechanism, but I think most people kind of know and have known for a while that lower reps, tend to result in more strength gains. But that's a great example, Dr. Roberts, where it's like, okay, well, now we're showing that for like an older population, we can actually apply that. And maybe if they're not going to be super consistent, or even if they think it's just going to be for a certain period, that might still confer benefits long-term for them, even if they're not always super consistent with it. So that's a great example.
Yeah. I think, man, can we sit down?
Yeah.
Because I was standing up originally thinking that we might walk through here, but Doc's going to get a biopsy needle to show you. So we're just going to have a seat here.
Sure.
There's Casey Sexton in the background. Say hi, Casey.
What's up, man? You're going to be famous.
Another graduate student. And
okay.
Nathan's in the background over there. I don't know if you can see him.
Yeah.
We
So
have
this is where the magic
spider.
happens.
Yeah. Yeah, some of it. This is the applied laboratory, and then if you want, we can take you down to the molecular lab here in a little bit.
And where are you exactly right now? This is Dr. Roberts' lab?
Yeah, this is Dr. Roberts' lab at Auburn University.
Okay, very cool, very cool.
Yeah.
So when can we expect a paper to be coming out for this? Are we talking like months from now?
So we're target date right now is going to be late February, early March.
Okay. All right, send it my way. First thing.
Yeah.
For sure, man.
Yeah, it should be open access, and yeah, it'll be freely available. Is the goal. So.
And I was going to say, Van, you're submitting some data to the ACSM conference.
Yes.
So once that gets accepted, I got to ask another colleague, but I think maybe we could post it. We'll just have to find out the rules and regulations of the red tape of publishing, if you will.
Right, sure. So, Cody, I know you train people, and what is your, I guess, like, what do you currently do in terms of training? Last I think we talked, you're a trainer for Stronger by Science with Greg Knuckles, right?
Yeah, I'm a coach for Stronger by Science.
And so, and you've been doing that for how many years?
5.
5. Okay. So in this time doing your own research, how much of an impact has what you've been doing in the laboratory setting affected how you're coaching individuals? And can you give maybe examples of how you're training people now compared to 4 or 5 years ago?
That's a good question. I would say it's notably different, but I wouldn't say it's like completely different.
Mm-hmm.
For example, like flashing back 5 years ago, I didn't recognize the importance for increasing set volume on a weekly basis to elicit like maximum hypertrophy over time. I was more of a proponent of intensity progressions, and it's not like I'm not a proponent of that now. I think a combination of each in general makes sense, but now I'm more aggressive with increasing set volume to a point, and that is the number of sets per muscle per week or per movement per week that's targeting a muscle. I tend to increase the number of sets on a weekly basis by more than I did 5 years ago. That's something that I've just picked up from the literature. And then, my own practical research and experience with clients that tends to work pretty well. What else? Frequency, something that I've changed. 5 years ago, it wasn't as common for me to emphasize training a certain muscle for muscle growth more than like twice a week. But I think that there's both empirical and anecdotal evidence that higher frequencies, at least for certain muscles, works pretty well, even on the order of 4 or 5 times a week. Can work well for some people. Those are 2 examples for hypertrophy. I can talk about strength if you want, or give more examples. Another example is I personally think, and this is something that we want to follow up, I'm trying to talk Dr. Roberts into a cell culture study and then eventually a training study. But I think metabolite accumulation, that is like training with lower loads and higher reps, is more effective for hypertrophy than some people would argue. Tension is obviously the key signal, but I do think that there's a place for emphasizing metabolic stress, lower loads for higher reps.
When you say high reps, you're talking 20, 30 reps or even higher?
Yeah, I mean, maybe even a little higher. I don't know how practically helpful it is to like give a number. I think it's more about the physiological stress that the muscle experiences, the nature of that, and you can do several different things to instigate that stressor. For example, like blood flow restriction training.
I was going to ask,
is an example. But yeah, I mean, those are just a few examples that I've modified my views on. And I wouldn't have, I don't think, unless I had been so heavy in the literature and then research.
Yeah.
So,
Do you utilize blood flow restriction yourself or in clients?
not often.
No.
No, I mean, a lot of people don't find it to be pleasant or comfortable or enjoyable.
Yeah, I imagine.
Personally, I know that Chris has experimented with BFR some. I remember one of the first times I interacted with Chris actually was at the rec center, and he had knee wraps around your. You were doing BFR training. It's just like, ow, this hurts. But I know that you've experimented with that some. So yeah, I don't do it often, but
Mhm.
I mean, if someone is willing to give it a shot, I think it's a somewhat of a novel stimulus, and it can introduce some variety into a program. But I don't think that it's make or break. I think it's a useful tool in certain contexts.
Yeah.
I think that
You
you can
mentioned the.
go ahead.
You mentioned that the frequency aspect. You said some muscle groups respond, in your opinion, to up to like 4 to 5 times a week. I had thought that some of the more recent research had shown that there's kind of a cap at maybe like 2 or 3. So, but you feel like there's some significant evidence out there to show even more than that is helpful. And what muscle groups are you referring to specifically, or do you think that's also independent?
Yeah, I would say it's going to be on an individualized basis. I wouldn't be comfortable saying like there's a lot of literature supporting that frequency.
Mm-hmm.
So I wasn't making that claim in the sense
Okay.
that there's several meta-analyses showing that higher frequencies can
Right.
work. But I think from my own training and working with clients, muscles like the abs and biceps and delts tend to be able to tolerate higher frequencies. Calves are another one that tend to be able to tolerate higher frequencies. And not just tolerate, but I think benefit from them. I mean, I think a simple gauge of that is if you have individuals do a few sets on, let's say, Sunday or Monday, and then you say, okay, when you're not sore or you don't feel like that muscle is fatigued, uh, introduce a few more sets.
Yeah.
People tend to be able to do that for those muscle groups every 48 hours or so. And that averages out to around 3 or 4 times a week, maybe.
Right. Right.
So I think using soreness as a gauge is an example of how you can kind of fine tune frequency, so long as set volume in any given session isn't too aggressive. I think that's
Mm-hmm.
something else to consider. That some of the benefits of frequency emerge from the improved ability to distribute volume over the course of the week. So, like if you do 10 sets in 2 sessions for 20 total sets, that's somewhat of a different physiological stress than doing 5 sets over the course of 4 sessions.
Sure.
And yeah, so maybe that was a helpful answer. I can elaborate if you want, or if you have any other questions.
It is. Yeah. I think it's interesting, and I know other people have talked about this too. How for most of, I guess, bodybuilding history, it was always kind of the bros because there really wasn't that scientific evidence. And then the scientific evidence comes out and it's like, oh, well, you guys are dumb and you're bros and you don't know what you're talking about. And certainly there is some of that. I mean, there is some nonsense out there for sure. But it is interesting when the research comes out and it's like, oh, wait, maybe they were correct. Like some of the higher rep stuff where they're saying, oh, like going for a pump. And now we're finding, well, wow, maybe those 30 rep sets to failure are helpful. Maybe that metabolite training is helpful. Maybe like hitting the muscle more often. I think there was maybe a paper or two on mind muscle connection. I'd have to go back and look at that. But just finding these things that are actually helpful that for maybe like 10 years ago, people were writing off and saying, well, there's no evidence for that. And now I think we're kind of getting this like meeting between the two to get the best of both worlds where we have evidence-based, but we're finding that some of that stuff that we thought was bro science, I mean, it was kind of bro science, but there is some truth to it. I just find that interesting.
Yeah, well, and I think that, part of the reason why we're starting to see that is more individuals that have years of training experience, whether that be personal training or being strength and conditioning coaches. We're seeing more of those individuals actually start to be involved in the research process. Like I know Dr. Roberts, who's in my opinion the GOAT muscle physiologist. He started out as a personal trainer, right, at Gold's Gym.
Right.
And yeah, Brad Schoenfeld's a great example, and there are several others that are now academics, but they started as trainers. And so they were able to, formulate research questions that they knew would have practical value. And I
Right.
know that, Chris also started as a personal trainer. And so that's really what got us intrigued in with the scientific processes. We wanted to optimize our own training and the training of our
Right.
friends, clients, athletes, etc. And so that's why I started getting into the scientific research process. So I think that's part of the reason, and we'll continue to see that happen. The gap bridged.
Yeah, no, I think it is really cool. And it doesn't, it shows that there are a lot of ways to get to that end goal. And one thing I actually had wrote down that I wanted to ask you about is it seems to be that, and I know certainly some people disagree with me, but in my opinion is that if you've been doing things correctly, and that's a huge caveat, if you're doing things correctly and you're at a mature age, you are probably going to have most of your results in 5 years or so, maybe 7. Now I look at like my own training. I started when I was 12, so yeah, I grew for 10 years because I started. There was puberty involved and all of that. So I could say, well, I put on 80 pounds, but I started at like 120 pounds, so it doesn't really count. But I think if you were to take like a mature, like a 20-year-old guy, if he's doing things correctly, let's say you were training him, by the time he's, I would say 25, 26, I personally think that almost all of the muscle mass is there. And then from a bodybuilding standpoint, you can come in more conditioned. Maybe you can work on a weak point, but it's mostly done. And then it becomes hard to stay motivated. I think you have to find a different why rather than, well, I'm going to put on this measurable amount of muscle mass. And so as a coach, do you have a lot of people come to you maybe when they're near their kind of ceiling thinking, well, now that I'm going to work with this great coach, I'm going to put on another 10 pounds of muscle. And I guess one is, do you feel that a lot of times you can put on more muscle than expected? But two, do you kind of have to like hedge their expectations so that they're not disappointed or have, an unrealistic goal?
Yeah, that's a good question. Honestly, I think what might be helpful is if Doc, you wanted to share some like physiological reasons why.
So I think your point is good, and Cody and I have had this conversation as Van. But my mentor, his name was Frank Booth, and he was a huge proponent of training during the formative years. So what that means is if you want to attain a peak muscle mass or even a peak bone mass by the age of 30, because we know that's kind of when you peak, you need to really start training prior to puberty. And there is actually a good paper on this in youth soccer players where they had 3 cohorts. I always go back to data because I don't work with athletes, these guys.
Yeah, right.
But the 3 cohorts where they were training something like between the ages of 11 to 13. The second group was 13 to 15. And then the third group was 15 to 17. And they followed them over a 2-year period, and they were resistance training. The youngest group saw the most robust, by far the most robust increase in strength after that 2-year training period. Now, they didn't do body composition, but I think that speaks to kind of what you're saying, Dave, in the sense that if you have a client, and I actually dealt with this one time at Gold's Gym when I was training, there was this guy that was trying to get into the military and pass the fitness test, and he was obese. He had never exercised as a kid. He lost a ton of weight, but he could never do a good push-up, man, because he had never exercised. And I don't know what it is about muscle during the youthful years that if you expose that muscle to training, right, that you basically set it up for success. And even if you don't train as much later on in life, you still have that foundational fitness. But yeah, there's a little bit of data in the soccer players on that. And I think if you've been training or you played youth sports or whatever, and then you get back into fitness, it's a lot easier to kind of realize a certain point of fitness that's pretty good. Whereas if you've never trained and you're trying to work out, man, just trying to gain muscle or strength is a huge uphill battle.
Yeah, I think. Yeah, I mean, it's certainly for muscle growth, and muscle growth is an interesting one because I think when it comes to skill, like skill in a sport, that's pretty clear that like if you don't start at a young age, you're just never going to be the best you could be. Like, of course, right? I've played tennis since I was young, but I've not like really played tennis, right? And it doesn't matter if I practice every day for the next year. I'm just not going to compete with somebody who's been doing it since they were like a little kid. You just develop it from such a young age. Muscle mass, I've always kind of considered that not necessarily to be the case because there isn't as much of that neurological component, it seems. Like, I think, if I recall, Jay Cutler didn't even start seriously training until he was like 18 years old or something like that. And there are certainly some guys who don't start until like their mid-20s, and then it's just like, what the hell just happened? This guy just blew up. So I still think that genetics for muscle mass kind of reigns supreme, but it seems like from what you're saying, even in terms of just pure muscle mass, there is an advantage to starting pretty young.
I think so. And Jay Cutler is a massive man, but also there's confounding factors with that example.
Sure. Yeah,
so
right.
I think for anybody that, the enhancement can work, right? But I think if you're going the natural route, like I said, from the N of 1 I experienced at Gold's Gym when I was training him, and then just kind of looking at some of this data in the youth training arena, if you will, it seems like, man, there's a huge advantage to start kind of pre-puberty if you want to maximize that peak, life, muscle mass, and strength aspect.
Yeah, but I think it's important to also note that there is research showing that individuals above 30, 40 years old, even up into their 50s and 60s, can still significantly improve their strength for certain, but even their muscle size. Now, when you get into the age strata of like 80 or so, then muscle's pretty stubborn at that point.
Right.
Senescence has kind of taken over, but I don't like discourage people that approach me that are 40 or 50 years old that want to make progress. But I do think that, and I know that's not what you're saying, like tell them that they're not going to improve and go work with someone else. But often I see clients in their 40s and 50s. I have some now. I have an individual that's 62 that just got to like 8% body fat and gained like 5 pounds of lean body mass after 6 months of training. Now, to Dr. Roberts' point, he had been training for several years. But I think a lot of people that are that age now haven't trained with the best structures or using the best nutritional strategies and behavioral strategies that we've discovered in the past 10 or 20 years. And several of those people can benefit from really logical training and nutrition because they've never really employed it.
Right.
So what do you think, Chris?
I think largely I agree with everything that Doc and Cody both said. I have had a few clients where I've made pretty sizable increases in lean tissue and strength, but to both of their points, they were in their mid to early 30s at the oldest. Most of the people that I work with that make really, really significant gains in both of those are in their 20s. And some of them have definitely started training well before they were out of high school, if you will.
Right.
So that pre-puberty all the way through puberty period and the teenage years.
Right. Yeah, it can be almost a little disheartening, and it's tough because you want realistic expectations. You also don't want to demotivate these people. And I even find that myself with just like new fitness goals or sports that I might entertain. And I'm only 28, so it's not like I'm old, but that knowledge of, like even like just something silly, like, okay, I was playing like racquetball and I was actually having a lot of fun with it, but I played, this guy was actually like 9th best in the world, and he kind of coached me that. And it was amazing playing with an athlete, even in a sport like that, playing somebody who was that good. And this guy is like 140 pounds, skinny guy. His right forearm is twice the size of his left. And he could hit this thing so hard. It was just remarkable. And he'd been playing since he was a little kid, but it was amazing. And just to kind of know that like I could never do that starting at my age now. Not that I couldn't improve, But for somebody like me who is competitive and who, like, if I do something, I really want to do it, it can be a little disheartening. So I think maybe you have to just kind of change your mindset again, like your why, like, why are you doing this? Focus on your improvement in health, that you can get bigger, you can get stronger, but you might not get a pro card unless you have like amazing genetics. Although that really applies to anybody. You're probably not going to get a pro card with how competitive things are nowadays, unless you have pretty solid genetics. But
yeah,
the overall point there.
And also, like, I just would generally discourage that train of thought. Like, what's the utility of thinking about that often?
Mm-hmm.
Like, I will never reach my best potential. Like, what will be the outcome of thinking that? So
right. Yeah, it's not helpful.
Yeah. So I try to encourage people to think of what they can achieve. Mm-hmm. And that's what we work for, and every second that we spend dwelling on something that we can't change, it's kind of a waste of time. So,
yeah. Do you ever, this is even like for my own like personal questioning, do you find that you might try to not steer them to a different goal, but help them find other ways to maybe find validation in what they're doing or achievement in what they're doing? So, like, for example, let's say I came to you and I said, hey, man, I've been training for 15 years and I've been doing it pretty, like, I've been following all the rules that we talk about and everything. Would you, in a situation like that, say, well, let's try to, I guess, what would you say to someone like that? If I said, hey, I'm trying to stay motivated, I want to progress somehow, but I don't know if I can make any more muscle or strength gains. Because I do have some people come to me and it's like, I know that they've been doing, like, even friends of mine, and they'll say, hey, like, what can I do? And in my head, I know, and this is probably more of like how to be a good coach type of question. In my head, I know, man, like, this guy has been training since he was like in high school and he's, maybe 30 years old. What do you say to somebody like that? Like you said, you want to make them look at what they can do, but still have realistic expectations. Hopefully that makes sense.
Really, it would just be a case-by-case basis. You touched on why. I think everyone should consider why they have a certain goal, and I try to start there. Why do you want to train for this fitness characteristic or for this goal? Mm-hmm. And then from there, we just would get into objective goal setting that's logical and realistic, and that would just be determined on a case-by-case basis. But one thing I can say that I do that I've found to be helpful for people is to make the process objective and give realistic timelines and goals that are achievable, but actively monitor the process and give them data-driven feedback so that they can appreciate if they are moving closer to their goal or not, and then we can make changes. Right. So yeah, I think setting clear timelines, and I've had good success with actually establishing some test dates, whether that be for body composition, rep max testing, VO2 max testing, body fat testing. I think periodically doing that helps people stay accountable, but it also gives them something to look forward to measure progress. And then from there, you just refine the precision of the goal, the subsequent goal. So yeah, it's kind of like a general approach.
Yeah, and I find that when people kind of step back and they do try to be objective about why they're doing it, they can be pretty creative in their why. If you look at Eric Helms, he just finished a series of competitions, and now he's actually doing strongman. And I think for him, it's like, well, I've been fairly successful in powerlifting, definitely successful in bodybuilding. He's 36, I think, and it's like this is a new avenue where he can have objective, concrete goals where, okay, I can do a log press, this weight or this many reps, and then progress from there. And I think something like that can keep people motivated. That's probably one of the biggest things that when I do train people is trying to keep them motivated, which is probably its own side topic in terms of what is objectively best versus what is best for this individual. Because you do certainly see that where you can tell somebody this is exactly, in theory, this is exactly what would be best for you to get the best results. But if they hate the routine or they just find it super boring, sometimes I have had people do stuff that I think is maybe a little silly, but I know they want to do it. Maybe they want a little bit more volume for arms, even if I don't think it's going to help them, or they think this exercise they saw somebody do at the gym was really cool. It's like, okay, go ahead, do that. We'll count it as cardio then. If it's just like some, I don't know, I've seen some people who are maybe a little older say, I saw this unique exercise at the gym. We'll go for it, just because for them it seems more fun and it keeps them motivated.
Yeah, I mean, if that's what it takes to help them achieve their longer term goals, like occasionally doing more machine curls than they should or pec flies and stuff
Right.
like that, if that's what it takes to keep them motivated and keep them training on a regular basis, then I think that makes total sense.
Yeah. So you mentioned the next area that you want to study maybe is, so you said you want to do it in cell culture first regarding that. Like, what were you trying to do in cell culture first before taking it to?
That's a different study. I mean, why don't you want to share kind of the vision with your analysis and like what outcome variables? Why don't you tell him and the listeners like what all you actually measured in this study, just to give an idea of how in depth it is.
Okay. So all in all, there's a ton of variables here. So we did DEXA measures at every time point for lean body mass and fat mass. And we also are going to segment that out to the legs. So differential responses between legs. We also did CT scans on each individual thigh to look at volumetric measures of differential responses. So we did those at pre and post, and we have MRI. We used a 3T MRI to capture just the muscle mass individually for the each leg. So those are the whole body type measures that we're looking at. But then as far as what we're doing with the muscle biopsy tissue, we're actually isolating that out for sarcoplasmic and myofibrillar fractions and sending that off for proteomic analysis. So we're looking for the protein responses to the training itself there to hopefully get a better understanding of what's happening with each of the different training paradigms. So that's really the whole analysis there. The one thing that I didn't mention is we also did ultrasound for vastus lateralis thickness and pennation angles to look at changes in that.
Involved.
Yeah, that's
seriously.
not it either.
Wow.
Yeah, and for all the haters out there on my dissertation, we included strength testing at the end of the study. So there's that, and we used what all did we test? Rep max and Biodex.
So we did Biodex at 120 degrees per second and 60 degrees per second flexion and extension for peak torque, peak power, and average power. And then they also did single leg press testing and single leg extension testing for each leg under similar conditions. So
yeah, wow, that is comprehensive.
I'll add, we got to thank Stu Phillips big time.
Yeah, shout out to Stu.
He's on Cody's committee, but then he sent us enough D2O to do the tracer analysis for both the myofibrillar and sarcoplasmic protein synthesis rates over the duration of the study. So to do that, you have to drink D2O, which is a heavier type of water, and you could buy a very nice car with the amount of D2O he gave us kind of on that house. So he's going to be a co-author on the paper, but he's been instrumental in this. And then Dr. Caitlin Young, great friend of all of ours. I've known him for years, but he did all the CT scans. He's an expert, I'd say world-class expert with the CT scan stuff. So, and then tons of people involved. Nate over there, trained every day.
Yeah, and man, it takes an army to pull these off, man. I mean, we just had 10 people here to do all of the data collection today. So
there's like 20 people that van basically organized for all this stuff. So yeah, kudos to all those folks.
I love how, with like social media and everything now, we've kind of brought this scientific side out, and it's just funny because you maybe like read if you're into like UFC or anything like that, you'll hear about like this fighter. It's like, man, like I would mess you up. Like that would be like a hater, and here the hater is like, oh man, you didn't even have ultrasound and MRI. Like, what are you thinking? This is...
Yeah, right. Yeah,
it gets frustrating. We've talked about it, but I get it. You can poke holes in any study, and we just put our one foot in front of the other is what I always tell Van. As long as we're moving one foot in front of the other, man, and trying to advance the science, that's the best we can do on this end. So
yeah, no, that's awesome stuff, guys. I'm sure everybody's looking forward to seeing the results of that. You said probably like February or so, right?
Correct.
Very cool. So I think that's pretty much everything I had on my end, is unless there's anything you guys wanted to add about the study, future research you're going to be doing, anything like that.
I mean, I'm good, man. I mean, we can round back up sometime soon and talk more about some of the other projects that are in the pipeline. But
Yeah, absolutely. And thank you guys for showing us the lab. Let me and the viewers get a view in
yeah,
there.
so do you want to here? We can walk around for a second if you want, just to get an idea. It's a beautiful facility.
Yeah, yeah, sure.
So this is the view. I don't know if you can see, but that's the pool and the rec center. But this is one biopsy table. There's treadmills, and then this is where the magic happened today. Doc actually pulled a biopsy needle out here to show. So that's what we actually performed the muscle biopsies with.
Fun.
So yeah, Doc and Chris did 30 of those today, along with
Cool.
30 of basically every other measurement. But yeah, this is
Just
like
so
the
people
applied
know,
lab.
this is Saturday right now, so never sleeps.
Yep. Yep. This is Saturday. So yeah, we've been here since about 5:30 this morning.
Oof.
So here's some of our posters. This is Dr. Roberts' office, but I'll take you to the molecular lab now and show you some of the equipment that we actually use to analyze the tissue. So once we extract the muscle tissue, it goes on liquid nitrogen in foils, and we'll bring it to the molecular lab, and we store it in a -80 freezer for downstream analyses. So this is the molecular and applied science lab. This is MASL, home sweet home. That's a centrifuge. Here's this is the -80 freezer. That's where the muscle samples are stored. A lot of tissue and flesh in there that people have donated. Several other freezers and a bunch of other lab equipment. Doc's gonna pull up some. What were you pulling up? Oh yeah, some actin and myosin bands, like the actual two contractile proteins. You can see a blot of that. But yeah, this is the lab. This is a PCR machine. We use that to measure gene expression. And then down the hall, there are like 5 other labs. So,
Wow.
pretty cool. But he's going to pull this up here.
Cool.
Yeah, so I don't know if you can see that, but long story short, this is myosin and this is actin from someone's muscle biopsy. And the way that we quantify it in relative, oh, there it is. Here we go. I pulled up 2 versions. My apologies. But we did a little sensitivity experiment looking at what the best amount of tissue we need to put in that assay is to get the best sensitivity. And so that, all these things are important to kind of bake into the recipe when you read the final product, like Cody's dissertation or what Dan's going to submit, because you want to make sure that your methods are really, really clean and reliable. So even beyond coming in on Saturday, it's a lot of legwork.
Yeah, sure.
In order to kind of figure things out, if that makes sense.
Yeah, definitely. Very involved.
Cool, man.
Well, all right, guys. Well, again, thank you. We'll put, I guess, Dr. Roberts, if you can send that paper you're talking about, I'll put that in the notes there. And we'll probably touch base again when that paper comes out. We'll kind of see how everything's going.
Sounds good, man. Yeah, thanks for having us on.